Okay, so in this quadratic function, so you want to graph this quadratic function, and the quadratic function is written in standard form, negative 3x squared plus 12x minus 7. To graph a quadratic function, remember you got to find the vertex, the axis of symmetry. There is always going to be a y-intercept. There may or may not be any x-intercepts, and you need to know whether the graph opens up or down. And if there are no x-intercepts, you have to find two other points. And then you're also maybe asked to find things like number 7. You may be asked to find the domain, range, whether the function is increasing, decreasing, and then the maximum and minimum value of the function. Okay, so let me just remind you, with all this that's given, there are some here that you can find very quickly. So for example, concavity, opening, the coefficient of x squared, when it's in standard form, the coefficient of x squared will tell you whether the graph opens up or down. So remember, in standard form, we have f of x equal ax squared plus bx plus c. The coefficient of x squared, a here, tells you whether the graph opens up or down. So remember, if a is positive, the parabola, remember the graph is a parabola, the parabola opens up. If a is negative, less than 0, the parabola opens down. So in our example here, notice that a is negative, right? A is negative 3. A is negative. So since a is negative, the parabola is going to open down. So right away, I know that I'm going to put the word down here. And the reason I put the word down is because a is negative 3, and which is negative. Okay. Now, so I know the concavity. I also know right away the domain. Since this is a polynomial function, the domain of any polynomial function is all real numbers. So right away, I know in interval notation that I can write negative infinity to infinity. All right. And then also, right away, I know I can find the y-intercept. A polynomial function, a quadratic function, there is always going to be a y-intercept. So if I want to find the y-intercept, here's what you do. So our function was f of x equal negative 3x squared plus 12x minus 7. So since this is a polynomial function, there has to be a y-intercept. There has to be a y-intercept. Since this is a polynomial function. And to find to find the y-intercept, you're going to let x equal 0. And from previous examples, you already know what the y-intercept is. That y-intercept has to be your constant. The y-intercept equals c. It has to be this constant. And it's true because look, if you let x be 0, I get y equal negative 3 times 0 squared plus 12 times 0 minus 7. So wherever you saw the variable x, you substituted 0. Well, this is 0, and then what's left? Negative 7, which is c, your constant. So that's equal to negative 7. So in this case, our y-intercept is equal to negative 7. So right away, I found those three things, those three items. So there's always going to be a y-intercept because this is a polynomial function. All polynomial functions, your graph is going to have a y-intercept. And they may or may not have an x-intercept, but there will always be a y-intercept. You knew right away whether it opened up or down, and you know that since this is a polynomial function, the domain has to be all real numbers. Okay, now let's go ahead and find the vertex. All right, so the vertex. So let me go write the function over. So f of x equal negative 3x squared plus 12x minus 7. Okay, so your vertex, and I'm going to remember your vertex is a point. So you know right away, let me just remind you about something. You know right away that the parabola opens down, right? The parabola opens down. So here's your vertex. So there's a vertex. So your vertex is a point, x, y. So to find the x-coordinate, of your vertex, you're going to use this formula. Negative b, the opposite of b, divided by 2a. So that's the x-coordinate of your vertex. So remember B and A come from these coefficients up here. So remember A is a coefficient of x squared, so that's negative 3. B is a coefficient of x, and that's positive 12. You have to make sure, though, you better make sure that numbers you put here are correct. Otherwise, your vertex is going to be incorrect, and all this information will be, well, for some of these, will be incorrect. All right, so remember, negative b means the opposite of b. So b is negative 3. This means the opposite of a negative 3. Divided by 2 times a, and a in this case is negative 3. I'm sorry, b is 12, excuse me. So the opposite of 12, excuse me, b is 12. So the opposite of 12 divided by 2 times a, which is negative 3. So we have a negative 12 divided by negative 6, right? Negative 12 divided by 2 times 3 is a negative 6, which is a positive 2. So my x-coordinate of my vertex, is 2. To find the y-coordinate, remember to find the y-coordinate, remember this is y, right? This is y. To find the y-coordinate, I find f of x, and x in this case is 2. So I find f of 2. So wherever we see the variable x, I'm going to substitute 2. So I get negative 3 times 2 squared plus 12 times 2 minus 7. And so 2 squared is 4. 4 times negative 3 is a negative 12. Plus, and then 12 times 2 is 24, and then minus 7. A negative 12 plus 24 is 12, and then 12 minus 7 is, what's that, 5? Okay, 5. All right, so my vertex is 2, 5. So that's your vertex. So now I can go to my graph, and I can plot the point 2, 5. So 2, 5 is up here. So there's 2, 5. So there's your vertex, 2, 5, right? And then, since I know that my vertex is 2, 5, I know the axis of symmetry right away. The axis of symmetry is just this x equal negative b over 2a. So just to remind you, this right here also happens to be the axis of symmetry. So the axis of symmetry is just x equal the opposite of b divided by 2a. It's just this number now. So it's x equal 2. The axis of symmetry is x equals 2. So my vertex, I forgot to write, my vertex is 2, 0. So there's your vertex. Vertex is a point, so make sure you use parentheses. And the axis of symmetry is always the x-coordinate of your vertex. So the axis of symmetry is x equal 2 in this case. So it's the x-coordinate of your vertex, okay? The x-coordinate of your vertex. The axis of symmetry is a vertical line. So it helps to draw that vertical line going through here. So the axis of symmetry is a vertical line that goes to the vertex. When naming a vertical line, you must always use an equation. So you're going to say x equal. Remember, the vertical line is x equal, and then it's x equal 2. So that's your axis of symmetry, x equal 2. So it's very important. It's very important. You just don't put the number 2 here, but that you put x equal 2. So the axis of symmetry is an equation. All right. Now, just before we go on, let me remind you. So the axis of symmetry is just the x-coordinate of your vertex. So to find the axis of symmetry, you're gonna find x equal the opposite of b divided by 2a. So that number, which is the x-coordinate of your vertex, is also the axis of symmetry, x equal. Remember though, the axis of symmetry is an equation, so you must use an equation. All right, so let's find the x-intercepts. So the x-intercepts, now let me show you something, remind you about something that we've talked about in the previous example as well. So remember, the axis of symmetry, the vertex is 2, 5, right? The vertex is located in the first quadrant. My parabola opens down, right? So I am going to have some x-intercepts. So there are x-intercepts. And there are 2 of them, so I must find them. So now we have to find these x-intercepts. There are some. All right, so to find the x-intercept, remember to find the x-intercept, we have to let y equal 0. So I'm going to take my function. Remember, your function is f of x equal, let me remind you, this is your function here. So f of x equal negative 3x squared plus 12x minus 7. So I'm going to set f of x equal to 0. That's your y. So I get negative 3x squared plus 12x minus 7 equals 0. This is not factorable, so you have to use the quadratic formula. You must use the quadratic formula. So remember, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. When using a quadratic formula, you have to substitute for a, b, and c. So be careful when you denote a, b, and c. So a is a coefficient of x squared, which is negative 3. B is a coefficient of x, which is a positive 12. And c is your constant, which is a negative 7. So that c here, remember that c here, negative 7, happens to also be your y-intercept. All right, so let's substitute these numbers into the quadratic formula. So we have the opposite of b. So b is 12. The opposite of 12 is a negative 12. We're finding the x-intercepts. It's negative 12 plus or minus the square root of b, which is 12 squared, b squared, and then minus 4ac. So minus 4 times a, which is negative 3, times c, which is negative 7. All of that's being divided by 2 times a, which is negative 3. So I get negative 12 plus or minus the square root of 12 squared is 144. A negative 4 times a negative 3 is a positive 12. And then a positive 12 times a negative 7. So let's see. Positive 12 times a negative 7 equals a negative 84. All of that's being divided by 2 times negative 3, which is a negative 6, equal negative 12 plus or minus the square root of 144 minus 84. So 144 minus 84 equals 60, divided by negative 6. Now 6 is not a perfect square, so these are irrational zeros or irrational roots. So these numbers are irrational because 6 is not a perfect square. So since those are irrational, I'm going to have to approximate my x-intercepts. So remember, these are x-intercepts that we're finding. So I'm going to have to approximate my x-intercepts. Now remember, we call them zeros because that's where this function is equal to 0. So those are your zeros. Those are going to be your x-intercepts. So x-intercepts and zeros are the same thing. So your x-intercepts, your zeros. Okay, that's where the function is 0. So remember, an x-intercept is where my y value is 0. Your 0 is where the function is equal to 0. That's where it crosses the x-axis. All right, so let's approximate this. Now let's remind ourselves how to do that on the calculator. So remember how you do this. You're going to say, look carefully, we're going to do the numerator first. Remember, there's a plus and a minus here. Let's do the plus first. So negative 12 plus the square root of 60, press equal. That's the numerator. Press equal now. So this is the numerator. It does not terminate. So don't terminate this. Just leave it like this. Then we're going to take all of that numerator and we're going to divide by negative 6. So say divide by, and then negative 6 equal, and then let's approximate the nearest tenth, so 0.7. So that's 0.7. So there's one of my approximations for the x-intercepts or for the zeros. Let's do the other one. So remember, there are 2 of them, right? Remember, there are 2 x-intercepts. All right, so let's do the other one. So negative 12 minus the square root of 60 this time. Square root of 60, then that's the numerator, so press equal now. So that's what the numerator is equal to. Then we're going to divide by negative 6, and let's approximate. So that's 3.3, right? 3.3. So there's my other x-intercept. So those are my 2 x-intercepts, 0.7 and 3.3. So I'm going to write 0.7, comma, and then 3.3. Don't put that in parentheses, because if you put in parentheses, it makes it look like a point or an interval. So these are just intercepts. There are 2 intercepts. Leave it like this. Now, before I go on, I want to remind you about something. So So remember, I just want to just show you something. So what I would do at this point is this. So these are x-intercepts, right? These are x-intercepts. I want to remind you about something. So here's the axis of symmetry. So if you add, so this axis of symmetry divides the segment that joins the x-intercepts. See, this is a segment that joins the x-intercepts, right? And so the axis of symmetry, so this is a segment, this is the midpoint. Y'all agree? So if I add those two x-intercepts and divide by 2, that better equal this number that I have for the axis of symmetry. All right, so remember, these are your x-intercepts. The midpoint of the segment that joins the x-intercepts is also going to be where the graph crosses, where the axis of symmetry crosses the x-axis. So if you add those two numbers together, 0.7 and 3.3, so look, 0.7 and then 3.3, 0.7 plus 3.3 equals, see 4? Remember, when finding midpoint, remember you add and divide by 2. So I add it, now I'm going to divide by 2. So I'm going to take this number, I'm going to divide by 2, press equal, you get 2, right? Well, what do you notice? That's also the axis of symmetry. That's what it's supposed to be. So whenever you add these two numbers and divide by 2, it better equal your axis of symmetry. So that's one way to check and see if you used your calculator correctly. That's one way. So always double check. Add those up, divide by 2, and verify that you ended up with your axis of symmetry, the number here. Okay, and then, all right, and so let's go ahead now and use our information to draw our graph. All right, so I already drew the axis of symmetry. I already drew my vertex. My y-intercept's -7. So here's -7 right here, right? So let me draw this a little bit better right here. So here's -7. Okay, now remember, once you know your y-intercept, you can tell me, and you have to tell me, I want you to tell me what other points on the graph. Well, if -7, if 0, -7 is on the graph, then this distance has to be the same as this distance, so this point has to be on the graph. All right, so these 2 points are symmetrical. So I need for you to tell me that. I need 1, 2, and then you have your 2 x-intercepts, and then you have your vertex. All right, so I need, if your y-intercept is anywhere in this coordinate plane, I need for you to tell me the other point. All right, and then your y-intercepts, we approximated, so do the best you can with approximation. So 0.7, 3.3. So let's say 0.7 is about here, okay? And let's say 3.3 is about here. So this distance and that distance have to be the same. So these 2 points, these 2 x-intercepts have to be symmetrical about the axis of symmetry. So notice that just like we did earlier, if I add those 2 x-intercepts together and divide by 2, it better be this, because that's the middle of those 2 points. And then we draw the graph and do the best you can with drawing the graph. You see how I'm doing it? I'm kind of like shading in a piece at a time, just like this. All right, do the best you can. Something like this. Draw your arrows and do the same thing here. Try as best you can to make it look symmetrical. Okay? If it doesn't look symmetrical, erase and do it again. All right, something like that. All right, so there's the graph. So 1, 2, 3, 4, 5. I drew 5 points. The vertex, the 2 x-intercepts, and then using the y-intercept with the point that's symmetrical to it, about the axis of symmetry. All right, so there's a graph, and now let's go ahead and answer the rest. So I want you to also tell me the range, and then where the graph is increasing, decreasing, and the minimum, maximum value. To do this, just to let you know, to do this, you did not have to know, to do those, you did not have to draw a good graph like we did here, okay? To do this, you just have to do the rest of this, you just have to draw a rough sketch. So for example, the vertex is 2, 5. That's in the first quadrant, 2, 5. And I know that my parabola opens down, so that's something like this, right? Opens down. Okay, now let's talk about the range. All right, so remember, the range is a set of y coordinates on the graph. So notice these arrows are pointing down. So I'm going from -infinity, and then I stop here. I stop at that vertex right here. So I need to know this y coordinate. So that y coordinate is 5, right? So y equals 5, correct? So I'm going from negative infinity all the way to my y coordinate, which is 5. So there's your range. So negative infinity to 5 with a bracket. Remember, we always go from smallest to largest. So go from bottom up. Okay. Now the maximum minimum is the next one that's easy to find. So notice that this vertex is a high point, right? High point. So that's a maximum. So that's a maximum point, correct? So when I ask you though, so we know it's a maximum point. When I ask you though for the maximum value, I'm asking for that y value. So that's that y value. So make sure you tell me the y value. Don't put the point here. Tell me the y value. So my y value is 5. So my range goes from negative infinity all the way to the largest y value of 5. And so 5 goes here. The interval where the function is increasing or decreasing. So as I go from left to right, notice that my y values are increasing, and then all of a sudden, so they're increasing here, right? And all of a sudden, my y values are decreasing. So remember, when finding the interval where it's increasing or decreasing, you're going along the x-axis. So from negative infinity to this x value here, which happens to be 2, x equals 2, which happens to be your axis of symmetry. So from negative infinity to 2, my y values are increasing. Negative infinity to 2. And remember, when we do increasing, decreasing, it's always parentheses. It's only with range and domain that if you have a number, you're going to use brackets. If you're looking at a polynomial function. All right, and then where it's decreasing, well, it's decreasing from 2 to infinity. See, my y values are decreasing in the interval from 2 to infinity. So from 2 to infinity. All right, and so that is, I believe, that's it. So that is how we're going to graph this quadratic function. H of x equals negative x squared plus 12x minus 7.